Now that we know how to count particles using Avogadro's number, it's time to talk about the mass of 1 mole of substance. We'll reaffirm the meanings of some terms, learn how to calculate molar masses, then use molar mass as a new conversion factor. Let's begin. When we discussed isotopes, we defined the atomic mass as the average mass of an atom in units of U, or atomic mass units. By extension, we can also calculate the molecular mass, or the average mass of a molecule in atomic mass units. Because atoms are so small, we don't typically use atomic mass units in everyday language, but we do rely on units of grams. So, how do we move from atomic mass units to grams? While an atomic mass unit is defined as the average mass of one atom, we can also define it as 1 gram divided by Avogadro's number. This means we can rightfully read the masses off the periodic table as atomic mass units, or, more usefully, as grams per mole of atoms. For example, the periodic table entry for carbon can be read as having a mass of 12.011 U, or 12.011 grams per mole, which we call the molar mass. The molar mass is a useful conversion factor to go from numbers of particles to mass of particles. Adding this to our list of terms, then, we can use formula mass to refer to the average mass of a formula unit of an atom, molecule, or ionic compound expressed in atomic mass units, but the molar mass refers to the mass of a substance in units of grams per mole. Let's see how we can use molar mass in an example. How many moles of aluminum are present in a can with a mass of 13.9 grams? First, we write down what we're given, grams of aluminum. We consult the periodic table to find the molar mass of aluminum is 26.982 grams per mole. Plugging that in as a conversion factor, we get 0.515 moles of aluminum. Most of the time, we'll be using the molar masses of compounds. To calculate the molar mass, you use the periodic table to add the masses of elements together in the proper ratios. For example, the mass of carbon monoxide requires you to add 12.011 to 15.999 to get 28.010 grams per mole. But the molar mass of carbon dioxide requires you to multiply the mass of oxygen by 2 before summing. Here's one for you to try. What is the molar mass of acetic acid, HC2H3O2? The molar mass for acetic acid can be calculated by adding the molar masses of all the atoms in one molecule. The mass of 1 mole acetic acid is therefore 60.052 grams per mole. What is the molar mass of calcium sulfate dihydrate? First, determine the formula of calcium sulfate dihydrate. Ca2+ and SO4 form a neutral compound in a 1:1 ratio. The prefix tells us there are 2 water molecules in the formula. From there, we look up the molar mass of each of the elements and sum the totals. The molar mass of a compound is another useful conversion factor when going between moles of a compound and mass of a compound. Let's step through an example to demonstrate. How many moles of sodium chloride are in 0.30 milligrams? First, we'll start with what we're given. We need to convert from milligrams to grams. Then we'll need the molar mass of sodium chloride. With that, we see that 0.30 milligrams of sodium chloride is only 5.1 times 10 to the negative 6th moles. Putting together all we've learned today, we now have a powerful method for starting at any given point in this chain, whether it be moles of compound, moles of atoms, or number of atoms, then converting to other units using the conversion factors calculated using Avogadro's number and the chemical formula. For example, we can calculate how many atoms are in 0.30 milligrams of sodium chloride from the previous example. We found that we had 5.1 times 10 to the negative 6 mole of sodium chloride. If we convert from mole of sodium chloride to moles of atoms, we get 6.2 times 10 to the 18th atoms. As always, I'll leave you with the parting thoughts of the authors.